what we're building towards, what we're doing. So the first lab that we have is using Prefect to pull data from the Spotify API, and then we have like these two methods, basically like our typical adapter pattern, right? Like the get playlist tracks that uses our client, right? It does the build client thing, and then does client dot get tracks or something like that, playlist items, I think. Um, and then this gets us back like kind of like our raw data from the API. And then what we do is we use this extract tracks info to clean up some of the data, just pull out what we want, and then we can save it to a CSV file. All right. And we use the write to CSV function to do that. Like in the lab after that, I expect that you're still working on this. That's fine. In the lab afterwards, what we'll then do is then take the CSV data and load it to Postgres. Okay, so we'll add basically like a new task called find recent files. And what that will do is actually what we'll do is we'll split this into multiple files, right? Like if this is remember, this is a playlist of like the top tracks in the US. So you can imagine that every day we basically pull make a new request, and then we save a new CSV file. And then what we'll do is, we don't want to reload like every CSV file to the database every single day. So instead, maybe what we'll do is we'll name each CSV file with the date, so it can be like today it would be one slash, I wish this was bigger. We got 1/24 slash, 24, whatever it is. Yeah, that makes sense. And then it would be like Spotify tracks. Okay? And then the next day it will be 1/25, 24, So now this find recent files, what will it do? I mean, like a generic way would be to just like only take the current day, but in case this thing breaks one day, like Prefect just whatever, like this is running forever, it's going to break someday. So a better way would actually be to see, we're going to load this data into here, so we want to see what is the last day that we've loaded data from. So in other words, we can maybe, if this thing has a date on it, like each one of our tracks has a date, maybe what we could do is find the most recent track. Like when was the last time we loaded in our data? And then, choose one day after that. So if we have a date on this and the date is 24, then when we call this find recent files, it will first go to the database, see the most recent date that we have data from, and then add one, right? And pull that file. Or basically every file not after the 24th. Okay, so again, if we miss one day, it will pick up both the 25th and the 26th. All right. So that's kind of like basically an ETL pipeline. This part right here, where we're saving data to CSV, this is called staging, typically, right? Which probably many of you have heard of. And the question is like, well, why do we have this extra step of staging just to load data into a database? There's many reasons why. And then also one is to say there's multiple reasons why, and then there's also many reasons not to do this. But the reasons for doing it is oftentimes you'll load. This will be for storing just your raw data. So here we are transforming some of the data, but typically you can imagine that we would just literally store all the data we got back from the API. Just say, okay, this isn't cleaned up at all, but we're going to just store it all. Okay? And what's the benefit of kind of storing this raw data? So, and why do it here? So one is basically by storing the raw data, if they decide to, say, remove parts of this, some of this information later on, we don't have to worry about it. Like we have it. So we are now holding on to kind of like as much data as possible, right? And it's untransformed. Let me make this bigger. Okay. We could do this maybe in the database. However, it costs more money, typically to store this data in the database than just store it in a CSV file, which lives on your computer, or more typically will live in like Amazon S3, which is very low cost. It's like pennies to store the data. So storing it in the CSV file is like pennies, whereas this is more pennies. It could be 3 times as much, something like that. All right. So the other thing, so we're holding on to more data. This data, remember, it's our like raw data. It's not too transformed. It's low value data, right? Or at least data that we don't know what the value of it is yet, but we just like want to hold on to it just in case one day we need it. Again, like it's probably not cost effective for us to store that in a database, but storing it in something like CSV files, that's more effective to do. And then other things are, there just may be certain kinds of data that don't really work well with this is more like text data, right, / unstructured data that maybe doesn't work well with a database, right? So you can imagine, like here we're pulling data from an API, but you could imagine that this is HTML data, right, and we're scraping it. And instead of just pulling out the key pieces of HTML that we want, like, information about the song, etc., we could store our entire HTML file here, right? Just pull the HTML, write it to a file, and save it. In this way, if we ever want to go back and get more, be like, oh, I also want this piece of information, it's not lost. We have it here. Okay, so this is kind of the pattern we're using, which is, having a staging area. And for right now, at least, it's just locally on CSV. But the idea is you store the raw data that maybe you don't want to really like query day to day, but you can always go back to, and then you have it, right? And it's relatively low cost for you to just hold on to it. So that's the idea. Whereas in analytics databases can cost a lot of money. You're like basically paying for a server to be running, like a computer to be running, and you're paying for the hard drive. So, this can add up. Make sense? Okay. The other thing is just to remember our Python. So just to review this again, some of this stuff. Remember, we have our console file that basically we're always running our code from the same folder. All right, like there are variations of that, but remember that the file that you run, you type in like Python in the file that you're running, everything is relative to that file. Okay, so that's why it's from Spotify extractor.listings adapter, right? And then if I go to the listings adapter, this has my various functions. Even if I go to the Spotify client, it's not relative to this the Spotify client folder that we're importing from, but rather relative from the file that's like being run, which is my console file. So that's why it's from Spotify extractor.settings, import client, okay, not from settings. Right, that would be relative to this file, but that's not the way Python works. It's relative to the file that you're running. Okay. And then other things just remember is like, right, there are tests. So you can remember just this technique that, if I run this thing, test get playlist tracks, that's importing get playlist tracks from the listings adapter. Let's go there. And then if you're just curious, like you want to kind of code this thing, just put a breakpoint in there. And then remember, run the tests. So now I can hopefully run pytest tests, and then we can run this test listings adapter. Is it not there? Hold on. ls tests. Oh, Spotify extractor. Sorry. Test listings adapter. Okay, and now this will run. And again, what happened? It hit our breakpoint. So now you can just kind of like code along in the console, right? Remember this? So now we can go to our listings adapter. We're right here. You can see like what is the playlist ID? And where does this come from? Well, you kind of know, right? It comes from this variable and this data getting passed through our function. Then this calls get playlist tracks. What should that do? That should probably go to our Spotify client, call this function, right? So we'll need to import that from, what is it? From the Spotify extractor dot Spotify client, import the build client function. Okay, sorry, not that. And then now we can use that function here. Okay, let's just do that one more time. I broke it. None type is not, oh, because maybe it's probably because I think it's breaking here. None type is not subscriptable. Let's see what's going on here. This is breaking in my, you can kind of see it, no client ID, right? So I just don't have this set up to actually pass a client ID. So where's that coming from? Settings here, and then this is coming from my .m file, which I probably don't have anything in. All right. So, but that's the general kind of workflow that you can move through, right? Is both using the console, as you remember, and also using the tests. Okay. So we're in this first lab, it's just going to be loading to the Spotify tracks. In the next lab, it will be, loading staging to the database. In a lab after that, it will actually then be connecting a Flask API to this database. So now Prefect is getting us the data, right? And you're still using your API to retrieve the data from the database and creating like a track model, right? As well as a Flask server. Okay? So that's kind of what we're building to. Yeah. Questions about this? This is gonna be a lot of like hands-on today. There's not much, I don't think, for me to say other than do lab reviews. All right, cool. So yeah, so more just like kind of process stuff, I think. You can see like we have this console.py, right, and that it calls the get playlist tracks and then passes through the playlist ID, which is obviously come from here. So this is our typical, like hit the API, do very little cleaning, if any. Then finally, like transform the data, right? Just select the attributes we want. And then finally, like kind of store it, right? Load the data, right, to CSV. So you can, like you can just kind of like use the console as a way to work with this, or you can use the tests. Either one is fine. Like if you go to the tests, it should show you the same type of thing. Here's a Spotify extractor, and then this first test the get playlist tracks, and then finally we extract the tracks info. And you can see it's like, what is this stuff? Well, this comes from data tracks, and then you can click on this. You see it's a list of dictionaries, right, of, I'm guessing, like, a track, one or two of them. All right, so you can kind of just see the structure of this. You can also, of course, put a breakpoint. Sorry about that. You can put a breakpoint in and run the tests. So if you look at this, and then you put a breakpoint here, you can put a breakpoint here, and this will run the first test, call your get playlist tracks, then hit the breakpoint, and you can see what this thing looks like. And then once you continue, then it will test this, pass through the list of tracks, pass through your playlist ID, and then hit another breakpoint here, right? Okay. Let's actually probably do it that way. So here's my test, so I can do PyTest, tests, what comes after that? Spotify extractor, test the listings adapter. All right, and now here we are in the get playlist tracks, which is right here. Okay, and I would, you can just look at like, what is this? This returns a dictionary. Notice it tells you total 50. What does that mean? Probably the size kind of the data set returned. Again, you can kind of explore this by doing .keys. And here you can see, like, there's basically a lot of APIs work like this, where they'll return, metadata. Like the href is probably the link that we made a request to. So here's the href. This is the link to the Spotify API that we made a request to. Limit 100, offset 0, get the tracks from this playlist, right? The items is probably like the payload, meaning like the actual data we want. The next is, like, I'm guessing if they're only, we ask for maybe more data than they're willing to give back. This is maybe a link to the next set, I'm not sure. And then the total, right, we just said that's the amount that they're giving us back. So even though we put limit 100, it seems like they're only giving us, we're only getting back 50. It could be because it's, I don't have it up, but it's actually coming from a Spotify playlist that you can see. Let's actually do that. If we go to the console, Spotify.com. I may have to go, give me 1 second. I may have to, oh, here it is. I'll share my screen. Like, I just have a Spotify account, so, if you just literally put in that ID, right, this was our ID. If you just paste that ID into just the regular Spotify app, it pulls up the playlist, right? And these are the top 50 songs. Your daily update of the most played tracks right now in the US, right? So that's what this is. So, okay, so here we go right here, we get this, and now we're in this listings, sorry about that, we're in this playlist, and now we'll get back some items. We called build client goes to our client, we kind of know about that. Call this function, we should be right here. So here's my playlist, and now we can call items. And we can also just confirm, I'm guessing, that this actually has 50 items in there. Okay, so that's good. And now this first step, all it does is ask you just to return, I think this is all it asks you to return. Let's take a look at the test again. So this is saying the length, right, of this return value should be 50. And if you look at the first element in this list, it should have keys of the following. So we can just confirm that. These will be my tracks. We already saw the length of this, of tracks, is 50. And if we select the first track, just like we're showing here, track square bracket 0 dot keys, we could even just copy this. This is the same thing, added by is a local track stuff. So this again is following that same kind of format of like metadata, essentially, and then like the payload, right? The real information that we're looking for. So that looks good. So we should be able to just return playlist items, right? So basically we're just only getting the items, like, right, the data that we want, and excluding or ignoring like the metadata. And then just, I'm guessing we can just run this, and we hit our next breakpoint, but we should be passing one test now, right? And now the next one, now we get to the next issue. So this is extract tracks info, and this passes through a list of tracks and the playlist ID, right? And again, you can kind of see how this works if you look at the console. So the idea is, right, you give me the playlist ID, I'll get back the playlist tracks, right, those items, and then we'll take those playlist tracks, right, or take those items and the playlist ID, and then we'll give you back a list of dictionaries of whatever we specify. I can't remember. So now let's go back, and we just put a breakpoint, right? So we're going to give you the tracks and the playlist ID, and you can confirm that if you go to the test, right, then it's the extract tracks. We pass through the playlist and the list of tracks, right? Playlist ID and the tracks. So we can just hit our breakpoint and take a look again. So now we're in our next breakpoint. Extract tracks info right here. And now you can play around, right? Like, what's tracks, right? It's a list of a lot of stuff. Let's look at the first one. We know that it's 50. Let's take a look at the first one. Also looks quite large. But what data type is it? Right, it's a dictionary. Right, you see this, the curly braces. So now we can do .keys, and we can see it has this track thing that looks promising. Let's go to there. This is probably a dictionary. It is. Let's take a look at this because it looks too large to figure out. .keys, and here's my ID. Okay, and what we need, I think, is for each one of these, we need the track ID, the ranking, the date, and the playlist ID. So we can just track square bracket 0. This is my first. This is just called my track. And we need this information. Okay? So we'll fill this in one by one. Okay, so the track ID is, we think, tracks, square bracket, this is the first track, square bracket track, square bracket ID. Okay, so that should be it. So we should be able to take the track, and the track ID will be track, square bracket track, right? And square bracket ID. And then the playlist ID is actually easy because we already have it. So the playlist ID is just you don't even have to do this, but the playlist ID is a playlist ID. All right. So now let's just run this again and hit our breakpoint and see if we did a good job so far. So we hit our breakpoint. We're now down here. Let's take a look at what some things are. The playlist ID, that should be simple. All right, good. All is right. And now let's look at just the track, right? So again, we take the list of tracks. That's all of them. But we just get the first one, and we assign that to equal track. Okay? So now we just set we're just going to use the first one as an example, and then do track, square bracket, track, square bracket ID. Let's just look at it. Track ID. That looks good. Okay? And now what's next? The ranking and the date. Let's do the ranking last. For the date, I think it's just, you just import date, and then it's just like today's date. So it's date.today. How do I know this? I Googled it. It's giving me none. Oh, why? Because I assigned date to equal none. But that was my mistake. All right, and then we can just convert that to a string, and now we're good. Again, like, you can Google that, but now we have the date. So we got the third one down. So again, like, what is my point in doing this is to show you the power, of course, of breaking things down. Just knock it out one by one, right? And now the ranking, that's the only thing left. So what we can do now, we did this for one track. So of course, it's our old technique from day one in the class, right? Now just go through the list. For track in the list of tracks, right? Loop through it. So for each of these like long, the list element in the list of dictionaries, we will pull out the track ID, get the ranking, which we'll figure out later, get the date, get the playlist ID, and then we can just, assign these to a dictionary. The track ID is track ID, the ranking is the ranking, and the date is the date, the playlist ID is the playlist ID. This is silly. We'll just remove that. Right, I just want to remove this line because it's coming from here. All right, the only thing left is the ranking. A lot of you think the ranking is the popularity. But anyway, it's not actually, right? Because this is popularity of 80, it seems like. But if you look at this, You can see that we can just confirm that we get back these tracks in order, right? So this is number 1. So if you look at the tracks, this first track, right, we did tracks square bracket 0. And then, where am I? For track, that should be right here. Do I not have tracks? Oh, don't know what I'm doing anymore. Track square bracket 0. I used a string. I don't know why I put quotes around this. That was dumb. Square bracket 0. Dot keys. So it's really, we know what it is. It's track to get back to like the real data here. And then let's look at the name. You see this? Bad idea, right? Wait, is this wrong? Oh, it's not in order. What? Am I looking at the wrong thing? I thought these came back in order. Is this not here? Maybe I'm looking at the wrong... Is that the name of the album? No. It previously came back in the right order. And maybe something's weird? I just want to see this one more time. Here's my track ID is from here, 37I9. This thing, right? Unless it got updated. No. So then when I retrieve it, it used to be the case that it was coming back in the order. Let's just put a breakpoint here. It used to be that the list was in the, the order. Let's take a look again. We'll get the first track. Yeah, it's still giving me that name. Track number 2. I wonder if that means track number 2 on the list. No. That's weird. It could be that I'm accessing this wrong. Let's be a little more careful. So we'll do tracks. Someone has an idea. That's good. Tracks.keys. This has my track. .keys. And now we have the name. Oh, and there's this track thing. Let's look at that. There's another track. And that's not helpful. Let's look at what this person's saying. This is the exact issue Austin and I saw. That's not helpful, Chris. I'm just kidding. So I don't know how to actually... I thought that these came back in order. But I guess I'm wrong. That's a bummer. Okay. Let's pretend that they came back in order. And I'll show you, just remind you how to solve that if that were true. Sorry about that, gang. So basically what I thought the right way to solve this was to loop through the list of tracks because I thought they came back in order. And we want the first track to be 1, to have a ranking of 1. And the second track in our list to have a ranking of 2. Right? And the way that you can do that is... Do I not have the collab? Hold on. I'll just show you. Is, we can have... let's just open up a collab. And basically the way that we can do that, imagine these are different tracks, right? I think a lot of you know this, right? You can basically just use enumerate for student in enumerate students. And it's for, this one I believe is the index, and then this will be the element. So if you wrap this in enumerate, right, then you'll get the index and the element at the same time, right? And it starts with 0, of course, but then you'll just do I plus 1. There are different ways to, do this, but, right, so what I thought, the way I have in my solution is enumerate tracks, I, and then just do like I plus 1. And that will be the ranking. And then you take the, so we can call this like the selected track or whatever you want. And then append. We'll call these my selected tracks. Dot append. Oh, I need to do this in the loop. Selects dot append selected track. All right. and then return it. So sorry that was confusing. I didn't realize. I guess sometimes they're returned in this right order, but that's not consistent. Instead of enumerate, it's something like, yeah, tracks.index plus 1. That's okay. So Julia was asking about doing it this way. So to get the ID, what if we just did this? You know? I'd say this is fine. You know, like it's not a big deal, but this is this is slower, you know? So if it's like, again, kind of the rule is like make it right, make it work, then make it work, make it right, then make it fast. So if you're doing like the finally in stage 3, the make it fast thing, just think about how something like this works, right? You have the list of tracks, and then you ask the index of that track. So what that means is it's going to have to go through the list of tracks one by one to figure out what's that index. Okay, so in other words, and it's doing that for every track. So this is for each track, go through every track, and basically the operations here, for those of you who, we haven't talked about big O yet, but this is big O of n squared, right? This is, so anyways, if you can do it the other way, if you can just use enumerate, that's better. It's faster. So we can just do the index plus 1. And yeah, that would be it. So now what do? We get back the data. We just select the items, right? Remove the metadata. Then we go through each one of the tracks. We pull out the ID. We get today's date and get the playlist ID, right? And then we store the ranking, and the ranking as well, which I guess this is wrong, but it's okay. Cool. So that should work. I think that works, at least in terms of passing the test. Date, let me just see this. Date where is not associated with a value. Date is date.today. Oh, I shouldn't do this. I wonder if it's just complaining that I'm like assigning it to the same thing. I just wonder if it's complaining about that. Let's just let's just move that line code. I probably shouldn't use the same variable, like the same variable date as is in the library. Yeah, so that worked. I don't understand this. This error message is not very helpful, to me at least, but we could probably Google it, and this was the issue, that I was referencing the library, this date from the library, and then assigning it to the same thing. So I just changed that by not doing that anymore. Okay, so that works. Then once you so these are the tools, like make a request to the API, pull out the information, take these selected tracks, and then write it to CSV. And again, like if you look at the console, you can see how that this stuff all stacks on top of one another, right? Get the data from the API, extract the tracked info, then take these selected tracks and write it to the CSV, okay? And then in the workflow, we're doing the same thing. We're just, get the playlist tracks. That's this first one. Get the playlist tracks. Then extract the track info, right? Extract the track info, write to the CSV. Write to the CSV. What we're doing is we're pulling these methods out from the adapter, right? From this listings adapter. So what I'm saying is import Spotify extractor.listings adapter as adapter, right? This as adapter means you get to refer to this module as the name adapter, right? And now I'm doing adapter.get playlist tracks. Why am I doing it that way? Why don't I just say right, like from this import everything? Because then because then I have this get playlist tracks calls get playlist tracks, right? And I like actually the fact that they're called the same thing, because it's like, it's very, I'm using the same name to basically perform the same operation, but I don't want to, if I do it this way, it's going to think I'm calling this method probably, and it's like a nested loop. So it just clears up that confusion both for Python and the reader if we're like, this is coming from this module, right? That's the whole idea. And now what happens, you run the flow will get the tracks, it will extract the data, and then write it to the CSV, and then this just calls your flow. Okay, so I think this would work. There's my Spotify workflow. It doesn't work. Can't locate the revision. This is such a weird error. Wow, what a beautiful error. Extract and write flows.py line 28 in Spotify workflow. You're complaining about this. I wonder if it's a weird error. Can't locate the revision. I wonder if I need to just reinstall the packages. But this code should feel okay. All right. I don't want to go through a rabbit hole of finding it, of debugging that error, unless anyone knows it. Is the flow function coming back without a return? Well, let's see. Yeah, it is, but I don't think that's the issue. Because it doesn't really have to, you know what I mean? Write to CSV is writing to is like saving the data to the data folder. Right, so it should be doing that. We could check. I think the first thing I would do would be to check, is this a Python problem or is this a prefect problem, by commenting this out and just calling my Python.
You comment the flow decorator.
Oh, I commented this out?
Yeah. Can you try it again?
Yes. That's not it. Let's comment this out. Let's just see, and then we'll be done after this. So I am importing it, and now I'm just going to try to run this as Python. Let's see if that works. That seems to work, right? Like we can delete this file, and it will generate a new one. You see that? It just generated a new one. So, and this has data in it. It seems right. So that works fine. I wonder if it's something with like my actual library. We'll see if, are you in a different Vim? That is very possible. Miles is asking, am I in like a different virtual environment? That seems, let's do con to deactivate. Let's just try to see if this is the issue. Do I have a Vim right here? No. Here's my code base. Let's do Python 3. So let's just create a virtual environment, -m viv. So create a virtual environment, source viv, right? And that, just to remind you, creates this folder. And that folder has the bin, which has this activate file. And then we'll just run source, right? Which is a bash command to run that activate file. Source venv bin activate. So that now activated this, and now we can do pip3 install -r requirements.txt. And now we're installing everything, hopefully. And then we'll run prefect. And now all I have to do is run, hopefully, this Python 3. Don't need to do -i. I don't remember I don't think I was. No module name prefect. Why?
You have it commented out.
Oh, I do? Oh, do I have it in, you mean in requirements? Or in,
No, in
the flow.
Oh, in the flow, I have it commented
in the
out.
flow, you just had it commented out.
Oh, I commented all this out. But it's saying no module. Let me just check my requirements. Oh, look at that, guys. Also,
Yeah. Gotta include prefab.
yeah, sorry about that, gang. So I forgot to put this in here, apparently. Install. Alright, and then this should work. If it doesn't work, we'll say goodbye anyway. I won't force you to watch me try to debug it. Cool. And then let's do the ETL, and then we'll do Python 3 Spotify workflow.py. This is feeling better, I think. Cool. Yeah, so this is working. Yeah. All right, cool. So that works. For the next lab, I know, the challenge of it is this issue of, right, like the fact that one, you'll have to write different data here, and then you'll have to kind of like look through the contents of this library to see, what's inside here. To do something like that, right, you can use the OS library to do that, right? So if I think there's something like def get recent files. You can import the OS. This stands for operating system, and the idea is like things that you can do on your operating system you can do here, and then it's like you can see it started to autocomplete for me. List the directory and then the path, right? So you can probably list the contents of the data directory, something like that, and that will return to you a list of files. Okay, and then from there you can, this is really writing some Python to find the files, of the after a certain date. Okay, so I'll let you questions about I don't know any of the things I went through. The main thing is, kind of like understand the flow. You can remember to use the console, put in the breakpoints, and then the overall thing was just take it one by one. I don't know how, take it one by one, right? Like put a breakpoint, do it for one track, just fill in, knock out each variable one by one, and do it just for a single track, and then move on to the loop, right? It's such a time saver.